Hi guys. So in today's video, we are going to be solving the heat IVVP using separation of variables. Notice that we have Dirichlet boundary conditions that are homogeneous. So to get started, separation of variables tells us to try to assume that the solution uxt is equal to a product of two functions, a product of a function of x and a function of t. In order for us to find a way to degenerate the PDA into two ODEs. So let's go ahead and do that. So we'll let uxt be equal to x of x times t of t, such that the PDE, well, ut, if we differentiate uxt with respect to t, we'll get xt prime, and that is equal to alpha, differentiate with respect to x twice, we get alpha x double prime t. Now, if we divide both sides by a factor of xt, we'll get on the left x double prime over x, and on the right we'll get t prime over t. We divide by alpha xt. And now look, alpha is just a constant, a proportion constant of the heat equation, but on the left-hand side, we only have x's. On the right-hand side, we only have t's. And now these are both rates. And since they don't commute with one another, in any other case, the only way they can commute with one another is if they're both constants. So if we'll just let these two equations be equal to some arbitrary constant minus lambda. Doing so gives us the two ODEs that we are trying to find. One of them being x double prime plus lambda x is equal to 0, and t prime plus lambda alpha t is equal to 0. Given, we also have our auxiliary conditions. So x of 0 t of t represents u0t is equal to xl t of t, and they are both 0. So let's go ahead and try to solve the first ODE we have, the x ODE. The x ODE is simply a linear second-order differential equation that is also homogeneous. So we can use the fundamental set from our regular differential equations class to help us solve it. The fundamental set can be found from the characteristic polynomial, which in this case will be m squared plus lambda is equal to 0. And that really implies that m is plus or minus the square root of lambda I, which further implied that the general solution, x of x, is a mixture of sines and cosines. So alpha sine of the complex part, x, plus b cosine root lambda x. And of course, a and b are constants to be found using the auxiliary conditions. So if we apply the first auxiliary condition, x of 0, a sine of 0, the sine of 0 will be 0, and that will cancel out the first term. B cosine of 0 will just be b, because cosine of 0 is 1, so b is equal to 0. And then we put x of l, well, now we have a sine root lambda of l, and b is 0, so that entire second term will go vanish. And we have to set this equal to 0. Now we have two cases. We have a case that a is equal to 0, or sine of root lambda l is equal to 0. Now if a is equal to 0, then we have a will 0 out this term, and since b is 0, b will 0 out this term, and we'll get 0 as a solution for x, which is the trivial solution, so we don't really care about that. So how about we try to look at the second case, sine of root lambda l is equal to 0. Now, when is sine 0? well, sine is 0 for every multiple of pi. So if we take the inverse sine of both sides, we'll get that root lambda L is equal to pi n. For n, that is an integer. And going further, we can simplify that. We can say that lambda then is equal to pi n over L squared. And since now n can be any integer, we must now index or label our lambda with a subscript n to signify which n we're using. Oh, I also must note this is for positive integers. Positive integers, since we are dealing with our domain being 0 to L. So now we can now put this, we have to subscript our x solution as well. So we have the solution x of n of x to be some constant n in front, we'll call it an, times sine and the square root of lambda n now. The square root and the square will cancel, so we'll get pi nx over L. So that is our first solution. Now for the x equation. Now for the t equation, we now know what lambda is, so we can sub that in. So the t equation is t prime plus alpha lambda t, but lambda here will be pi n over L squared times t is equal to 0. And again, we know how to solve this from our ODE class. This is simply a first order linear differential equation that is homogeneous. The fundamental set here will be m plus alpha pi n over L squared is equal to 0. So m is really minus alpha pi n over L squared, which in turn means that Tn of t, the solution for the t equation, will be some constant Bn times e to the minus alpha pi n over L squared t. Or in other words, since we have xn and tn, un of xt will be their product, and we get that a, and we get that x of n, so a sine of pi nx over L times bn e to the minus alpha pi n over L squared to the t. But notice, an is a constant, bn is a constant. So if we take their sum, or take their product, that will also be a constant. We'll call that Cn then. So we'll get Cn sine n pi x over L times e to the minus alpha pi n over L squared t. And now, this is for any particular n. But it turns out, by the superposition principle, we can have that any linear combination of these two, this product, will also be a solution. So we'll let uxt be equal to the sum, as n goes from 1 to infinity, of unxt, or in this case, sine n pi x over L, e to the minus alpha pi n over L squared t. Alright, great. So this is our general solution. But what we really want to find is what this Cn is. This Cn. And we also need to use our initial condition that ux0 is equal to phi x. So let's go ahead and do that. We'll get that ux0 is equal to simply the sum from n equals 1 to infinity of Cn sine of n pi x over L, And notice that this t will zero out the exponent for e, and e to the 0 will be 1, so we simply have this. But if you guys notice, this is a Fourier sine series. And that means we know what that is. If you guys recall, we derived the Fourier sine series and their coefficients to be as such. This coefficient is nothing but the integral from 0 to L of the phi x times sine n pi x over L dx. Oh, we also have to set this equal to 5x, of course. And so, if we put it all together, our final solution of this initial boundary value problem, the uxt is equal to the sum from n equals 1 to infinity of the integral from 0 to L of phi x times sine n pi x over L. Let me write this. X over L dx, close brackets, sine of n pi x over L times e to the minus alpha n pi over L squared t. And that is our final solution. And also a good place to stop.